So I'm Marko. I go by as Marko on Twitter. I'm a developer and co-founder of a company called Render Text. We're making a continuous integration and deployment service called Semaphore. In general, we kind of compete on being easy and really fast. So everything that I'm going to kind of talk about today comes from this product making perspective. So I'm going to talk about like applying microservices, but not really because it's cool. I don't care about that. I care about like things that help us work better and be kind of more productive. And of course, we're in Chicago, so big shout out to like Basecamp people for getting real philosophy. It's a big inspiration for me. So scaling up, why even talk about this? So the whole point of it is basically to avoid trouble. And there's a whole range of like technical and social challenges which kind of come up. And I think it's basically, there are two major things. One is degraded system performance and stability, and another are slow development cycles. So not being able to make things in a time frame that's kind of meaningful. And degraded system performance and instability typically come up in monolithic systems, such as our beloved Rails apps when they grow a little bit. And some of the typical sort of manifestations include like ridiculous things like maybe 1% of your code bringing your entire website down. For example, like I don't know, email sending, using up all database connections, and when it stalls, it's like everything goes down. Typically, we over time accumulate a lot of background workers, and the size of execution that's happening in background actually vastly outgrows the MVC web components. And in general, we kind of see when we make change in one part of the system, unexpectedly there's trouble and consequences in seemingly logically unrelated parts of the system. So this kind of could start keeping your team in some kind of perpetual state of emergency. And you know, when things start taking more time than usual, kind of the classical like CI question to evaluate yourself is like, how long does it take your team to ship a hotfix to production? And that's like a very technical question, and not having an optimal answer can be very obvious to your users in case of an outage. What's kind of less obvious is how these slower cycles are affecting the company over a longer period of time. So how long does it take a team to get an idea about a small product like improvement, an experiment, to something that's actually running in production? And if it's like weeks or months maybe, then you know, in the long run, like, or even mid-run, that company may not even exist. So Michael from Highrise talked about momentum earlier today. That's really important. And we do get there through compound effects of complex code bases. So if a CI build is taking longer than just a few minutes, basically that's already too long. And you can work around that. Like Semaphore has a feature that can automatically parallelize a Ruby test suite. So our own largest test suite takes like 45 minutes, but we can bring it down to like 3 or 4. But deployment can get slow too because of a long list of dependencies and assets to compile and copy and so on. When there's a ton of code, then it kind of starts, it takes months for new people to become kind of comfortable making meaningful contributions. And because of that, and because it's all ultimately one endpoint, one thing on PagerDuty, you sort of keep on adding more and more responsibilities to the people that have been with the code base from the early days. Whenever there's a problem, you need to like switch to making sure that vulnerability is fixed. So you sort of context switch between working on new stuff and fixing things. If we discover new use cases that for which we want to experiment with some new technology, that becomes real difficult. We have this huge gravity pull that's just pulling all our code and effort in one place. Because of this, there's kind of fear creeping in the team. It's perfectly rational because you do things and trouble occurs, and this kind of contributes to kind of morale dropping. And I've been kind of thinking like, what are we doing wrong here? Can we sort of come up with something that's approaching a rule of thumb, like how much code or what kind of code is it okay to write in Rails app, and where can we say, okay, from this point you're kind of proceeding on your own safety. So you might have seen this like question, and it's like if you can build a well-structured monolith, what makes you think that microservices is the answer? I think this can be a little misleading because it's really hard to kind of discuss structure, like you have maybe different interpretations of that. I'm actually assuming that code quality is not really an issue. Like if you consistently do behavior-driven development, you probably have it at a pretty high level. And sort of challenges come up with scale anyway, so design is not really an issue here. Or is it? Like if you think about it, what are we working with? Ruby is a very nice programming language, but it also happens to have a global interpreter lock. And most of us, when we write the code, we create lots of mutable state. Rails is a model view controller framework, model view controller. And it makes writing web apps that fit that very easy. And partly because of Ruby's dynamic features, partly because it just abstracts away a long list of stuff that we don't need to worry about, which is also known as magic. But like if you just look at Active Record is a pattern taken out of a like 500-page book about enterprise software architecture patterns. And one way of thinking about it is that actually your runtime when you're just starting a new Rails app has a lot of complexity going on already. So maybe a question can be like how many additional patterns and modes of behavior is it okay to put in this single runtime before it begins to kind of break. And you know, the code as you read it can appear to be simple to understand. However, if it kind of starts giving you trouble in production that they're difficult to solve, then actually it's not really a good design. And we kind of have to differentiate between apps that are really mostly serving web pages, doing CRUD, and having some additional services for sending email and so on. And applications that are web, but only in like 20%, and the rest is just some, you know, domain logic, which is living in its own world and not really responding to web requests. So maybe the moment when you start sort of considering how to structure your lib folder or wherever you put your business logic in a Rails app, you're already kind of exceeding the complexity that can be safely scaled up to a large volume of users and data and requests. Because what we're doing that, we're effectively growing multiple applications in a single runtime. When that needs high traffic and large volumes of data, that's when all this trouble starts to occur. But that's not what we want. Like, we want to be awesome and creative and make products as quickly as possible. Whether it's like commercial products or open source projects, whatever it is. So any change that we consider should be contributing to bringing us closer to this goal. And the whole idea of microservices is just applying the basic principle from the engineering mindset. Like if something is kind of hard, let's break it up into smaller problems so that they're easier to solve. At that point, if you decide to try that, you're basically building a distributed system of multiple components. And I think that it's a very important decision how these services then communicate. And there are two major paths. So if you have been doing, like myself, like if you've been doing like web development for a while, you may be a little biased and just think, okay, I'm going to make like REST APIs and we're going to communicate via HTTP. And that's very simple to kind of understand and reason about. In general, that's actually not what it's about. It's always about like what happens in cases of failure. If we have like service A, service B communicating, if there's a bug in service B, if it has local operational problems like not being able to connect to a database or something, service A should hopefully try to do something to work around it. So maybe it can like retry sending the requests. The question is then how often, at which intervals, like what happens if service B has not recovered quickly enough, which is almost always the case. So unless you sort of start building complex logic to work around HTTP as a protocol itself, you pretty much end up losing your data and not doing the work that you should. Synchronous communication is, of course, blocking by definition. It's an abstraction on top of a world, which is, our physical world is very asynchronous by nature. And if there's like some contention in the communication, you have like service A is not able to do any other work. So then we kind of think about let's create threads or processes, maybe not threads in Ruby. But then we create lots of new problems like avoiding contention, shared state, keeping data consistent, and we enter the phase of like making concurrent programming work, which is probably one of the hardest things in our job, really. So I would say that synchronous communication can make the system even more fragile because it increases temporal and location coupling between components. So they all need to be perfectly healthy at the same time in order for communication to work well, and they all know about each other, like they know the exact locations, and they're very hardwired. So this makes the system actually more difficult to scale, which is what we kind of started with as a goal. So the alternative is basically asynchronous communication. And this is the primary thing that I wanted to talk about today. Asynchronous communication, you can think of it as a to-do based communication. So I can assign, there's another service that I want to communicate with. I'm going to assign it a to-do with a payload. And it can do its work whenever it's ready. So in normal circumstances, that means immediately. In exceptional circumstances, that means whenever it recovers. And it can then proceed wherever it left off and do its work on its own time. It's actually a lot more relaxed way of operating if you think about it. And the simple kind of way of realizing this is by using some kind of a distributed queue as a mediator between services. And maybe we can go in an example just so it's not too abstract. So let's say that your system needs to react to third-party webhooks of some kind and do some work then. Of course, the monolith approach is to just add another route to your monolith application and perform everything there. The problem is because it's doing 100 other things, and there's a very high chance that it might go down at some point during the month, or so you will basically miss these webhooks. The microservices approach would be to build a very small, like tiny service, whose job is just to receive this the payload from webhooks, put that verbatim payload on a queue, and that's it. And on the other end, we have like consuming microservice, which is listening to the same queue and taking messages one by one, passing the payload to the main service, which is doing the actual useful work. And only after it has received a successful response, it removes the message from the queue and moves on to the next one. So these new services are a bit so small that they're actually infinitely easier to kind of keep bug-free and operate comparing to just the huge monolith. And of course, the queue now is kind of like a point of failure, but it's a much more isolated one comparing to one huge runtime. And the best thing that you can do to yourself is pick a mature technology that you can trust the way you trust, I don't know, Postgres database. Our experiences at Semaphore have been that we've been very happy with RabbitMQ. It's been under development for like 9 years now, I think. It's based on Erlang, so being fault tolerant is kind of in its DNA. And very importantly, you can kind of go through their tutorials and start making something with it on the same day. I'm going to show you some actual code, like just to get a sense of how these services actually look like. So they're very small. Here we have an example like a webhook receiving microservice. It can be like a tiny Sinatra thing where you react to one post endpoint. You get your payload from the parameters, you publish it on a RabbitMQ queue. And the RabbitQ connection class, you can just sort of think of it as a boilerplate for connecting to Rabbit, which you can figure out from the basic tutorials. On the other end, we have a consumer which is subscribed to the same queue. Because it's JSON, it kind of parses that. Then let's say we want to save it in a database for future reference. And here, just as an illustration, how you kind of start reevaluating your default database choices. Here, I'm actually using Active Records Postgres adapter and taking advantage of Postgres JSON-B binary representation of JSON. So it basically means you get NoSQL database running on a rock-solid system. After that, we might want to extract a couple of actually interesting fields from the payload that we received and send it to the main process. And finally, we have this manual acknowledgement step where, only after everything else previously has succeeded, we were able to sort of say, okay, this message is done. Let's move on to the next thing. Of course, using queues in this buffer-like pattern is a kind of limited thing. The producer needs to specify the exact name of the queue. And on the other end, you can actually have only one service consuming messages. But when you start sort of building stuff with this message passing style, pretty soon you end up in a situation where you have one message, but you want to build multiple consumers that do different things, but based on the same message. And the general pattern that describes this is called publish-subscribe. It's been a long, it's been a long time that it's been introduced. So the general idea is that producers send messages somewhere without knowing how many consumers there are, even if they exist at all. On the other hand, consumers can be brought to production at any rate without modifying the producer and start consuming messages and do their work. So I'm going to share an example from how we kind of started with something that's a very simple queue-based buffer-like thing, and then we evolved towards pub/sub. So Semaphore is a continuous integration and deployment service, and basically when you do git push, we detect that, and based on previously supplied configuration, or it can be automatically inferred, we run a new CI build. And each CI build can consist of any number of parallel jobs to speed things up, and every job runs on any available build server. So what's kind of most fragile here is this communication with the build servers. And in the early days, this was all done by a monolith. And for some of the reasons that I kind of mentioned earlier, we introduced a separate microservice for this. And in between, we were using RabbitMQ. So to give you a sense how it actually works, I'll give you a quick sort of overview of how RabbitMQ essentials. So in RabbitMQ, you publish messages on what they call an exchange. It's like a box where you send messages. And on the other end, you can connect any number of queues to a single exchange with or without some pattern matching criteria. So that would be because you want to receive just a subset of messages, or you can just receive all of them. You can also route exchanges between each other, but for now, let's focus on this. So that means that in our case, the monolith will be sending messages about new queues that need to be somehow taken care of on an exchange. And a microservice would connect its queue to this exchange and sort of process each new event as it happens and schedule the jobs on each build server. Later on, the build servers would take the messages that they received, modify them, and publish on the same exchange information about the jobs entering further states, like started or finished. So we had this pool of messages describing the life cycle of jobs on one exchange. And what we were able to do then very quickly is write new services that do something interesting with this without actually kind of worrying anymore about how everything else works. So one microservice would be responsible for measuring metrics, like are we is everything happening fast enough? Are we getting Git repository cache hits at a good rate, and so on? Another would be like keeping some of the data in a local database and providing like real-time capacity visualizations. And what was really cool is that developers who worked on these did not need to be familiar with the monolith at all, or how everything else works, and in fact we're not. And we're able to be very productive. And when you think about it, it's like that's how it should be. Like you should, to the largest extent possible, be focused only on the job, on the thing that you're creating, and not the rest of the things. So services designed this way end up being very, very small, so small that they're basically disposable. If for whatever reason we need to replace them with a better implementation, we can do that relatively cheaply. And what's micro about them isn't necessarily the number of lines of code, but their scope. Ideally, you should be able to describe a microservice without saying end. So they are like very easy to kind of reason about, to debug. In practice, they either break completely or just work. And they run in a single threaded environment and very, very fast. And I would say it's very like liberating and personally to me exciting to be starting from a blank slate so often. So instead of kind of being burdened by all the like history of and big code base around you, like finding a way to work with it, to not mess it up too much, you have this like simple contract where you need to react and understand one particular message format and do one thing based on that. And of course, doing one thing well is the Unix philosophy. And the way I see it, like if you're working under a paradigm which leads you towards this, I think that's a pretty good sign. And when you generally start evolving your system with this approach, you kind of see your whole tool chain kind of naturally want to diversify. So hopefully you're packaging your stuff in containers, so this deployment is standardized, so you can easily experiment and bring new languages to production. For example, at Semaphore, we adopted Elixir as a go-to language for like the mission-critical parts of the system. Instead of having one large database operated by Monolith, which is a very enterprisey thing, you have like smaller databases popping up, maybe some data overlap because it's more convenient for small services to have some data locally. But there's always one source of truth for every piece of information, of course. And because you're creating new databases often, or doesn't have to be often, just you're creating new databases, you kind of start evaluating, like maybe I can use NoSQL this time, or maybe Redis is better than a relational database, or whatever works. Kind of the hard thing about microservices is that it's a new way of kind of thinking and building a system, but it's still kind of harder to actually run and operate them. So there's a pretty high bar still for like actually having them in production. So the major thing is like deploying a new service should take minutes, ideally. And it should already have like some log collection, basic health checks running. It should appear as some dashboard, which is all part of like continuous delivery practices. So you should definitely automate, of course, the build and deploy phases. And Semaphore can help with that. And you need to have or evolve towards a culture where developers really own what they write. As the Werner Vogels from Amazon said, if you build it, you run it. So it's not like developers are responsible only for the code they write, but they should also be responsible for running it in production, for security, and even the costs of that code. So am I saying that like this is how we should all like build all web applications? Definitely not. But I think it's a pretty good idea to evaluate if you have a piece of the system where like data loss is definitely not an option. Or you're dealing with some heavy load, so you want to first isolate that part of the system and second optimize it later in a quick feedback loop. Or if you're dealing with like computationally intensive stuff, so whatever is a background worker that's doing some non-trivial stuff, that's also a good candidate for a microservice. Or when you're dealing with like third-party disparate sources of data, which you don't fully control yourself. And I think that like so far a lot of like talk about microservices has been coming from very large companies, and they sort of brag about like how many there are, or huge graphs of services, but which can be a little bit discouraging. But I think that for example at Semaphore we're only about like a dozen engineers, and only a couple have actually started building first microservices. So I think if you have like the right kind of DevOps capabilities, or you just buy into it, then it's really possible today. So that's pretty much all I had. If you have any questions or you want to talk about this, please find me here today and tomorrow, or write me at Twitter or email. If you want to have if you would like your CI service to just work nicely in the cloud, check out semaphoreCI.com. So thank you.